Okay, so in the previous tutorial I just mentioned module headers. So this tutorial has just a few slides, a handful of slides, and talk more about them because we feel that it's the most important piece of documentation that you as a user need to know about and look at when you're using Spice. So this tutorial will talk about the purpose of the module headers, where these module headers are located in various toolkits, and then we're going to take a look at the typical header, but that I'm going to do interactively. I'll replug my computer and I'll show such a header to you so you can get a feel of what the section and kinds of documentation are. So Nave uses module headers to provide detailed information describing how to use a module. In Fortran, C, and MATLAB toolkits, these headers are just comment blocks which reside at the top of that specific module. In the IDL toolkit, where we don't provide IDL source code because the bridge is built in C, these exist only as independent files in the HTML tree. So for IDL, if you look in the IC directory under source, you're not going to find any of these headers, while for the other languages, that's where the regional header information is. So all toolkit distributions include plain text and HTML versions of the module headers. This is actually not correct for IDL, because for IDL, it's only HTML version that's included. But HTML version is usually the one that you should look at. Of course, the reason is obvious. With HTML comes structure, with it come links to other headers, with it come links to reference documents, and so on. The next few charts talk about where these modules are located. So the plain text versions are located under source directory, Spice Lib subdirectory, where the main library modules are, and they will be at the top of the files with extension F or 4, which are Fortran source code. In most cases, a single header will be at the top of the source code, but if a Fortran module has multiple entry points, then each of these entry points will have its own header, which describes all the information that's specific to that functionality. A good example is a keeper routine, which has entries for furnish, ktotal, kinfo, and other and unload routines that deal with loading and unloading Spice kernels and getting information about loaded kernels. For HTML versions, you need to look at toolkit doc, HTML Spice Lib index file, but even better, if you just load the high-level index, which resides under HTML directory, then there will be a reference Spice API reference document link, which will point to this index, and I'll show it when we look through the documentation in a few minutes. For C, the plain text versions will be under source cspice directory at the top of the files with suffix _c.c. HTML versions will be at this location. For IDL, two types of headers are provided. The headers in HTML format will be under this directory pointed from this index, but these headers do not provide complete information. So they're not as abbreviated as SpicyPy, which has almost nothing in it. They do provide more extended information about inputs and outputs, and they do provide example and version information, but they do not provide full information about exceptions. They do not provide full information about particulars. So in the case of IC, you would also need to look at the cspice headers, and as I already pointed out, they're available at these locations. So similar situation is for mice. You can look at mice HTML format headers if you load this index. And you can also see these headers if you type help command from MATLAB. For example, help followed by the name of API will dump on the screen the full header for that API. As with IC, you would need to look at the cspice headers for more details about those modules. So, for example, as a reminder, the name of the routine for which you need to look is slightly different in different languages. SPKEZR in Fortran, lowercase SPKEZR C in C, cspice _ SPKEZR and IC and mice. Okay. So we replug computers. I'll try to. me change how I show the screen. A little better. So this is how top-level index for SPICE toolkit documentation looks. In this case, we're looking at CSpice toolkit hyperlink documentation. And it's different from the index file that comes standard in generic toolkit by the fact that in this lesson-specific version, we actually have links to the lessons that you will be doing. Each of you who downloaded the lessons package and installed it under the toolkit doc.html subdirectory should get an index that looks like this, in which all the links would work, and they would either point to the generic documents that come with the toolkit, or they will point to lessons or diagrams that are specific to the lessons. Now, if you look at this toolkit, I'm going to skip the lesson part, this document, I'm going to skip the lesson part of the one. You will see that each of these indexes actually includes links to the introduction to SPICE, introduction to C implementation for the C toolkit, the document describing toolkit contents, document called most used API, which is available for each toolkit version, and it has the link to the API reference guide. So this index includes a link to every single public SPICE API that is available in a particular toolkit. And if you look for a particular API, for example, I'll look for SPK-EZR, I'll click S, and I will scroll down to SPK-EZR. There it is. So you will see the header for this API in HTML format. Looking at this header, you will see a quick link, set of quick links that will take you to different sections of this header. I'm not going to click on them, I'm just going to scroll through it. These headers will have slightly different structure in different languages. In this case, for C, they would provide the API calling sequence, short description of the API, links to reference subsystem documents such as SDK required reading, native IDs required reading. They will have brief description of input and outputs, given the argument, the type of argument, and brief description of that argument. And then they will have a section with detailed description of inputs, and then the section with detailed description of outputs. If there are any parameters that are specific for this module, they're going to be listed and described in the section parameters. The exceptions section will list all the SPICE errors that the module will generate in the case of you providing incorrect inputs or some data not being available. There will be file sections that talks about what kinds of kernels would be needed for this routine to do its job. The particular sections will have discussions of certain implementation, certain concepts that are important for you to understand how this module functions. For example, in the case of SPK-EZR, it will have description of aberration corrections, one-way lifetime, stellar aberrations, and such. Sometimes with ASCII diagrams and formulas. So in this case, it's pretty involved routine. And then there will be a section that will provide an example, and in many cases for the high-level routines and more modern routines, this will be a cut-and-paste type example that you can cut and paste and execute given that you provided downloaded the same kernels. It will have some restrictions, an explanation of some restrictions on usage of this routine, some literature references. In this case, it's just required reading for the subsystem, who was the author of this routine, and then extensive version information about this routine. So this information will look very similar for other languages, except in IDL and MATLAB, you will have fewer sections. You will only have descriptions of inputs and outputs, a calling sequence, example, but for many categories of information, such as particulars and exceptions, instead it will provide a link to the CSpice routine, which it is wrapping, and that's what you will need to look at. Okay? So it's very important for you to learn how to navigate freely in these headers, because when you will be asked to do certain assignment in the lesson, you will need to find the routine that's supposed to do it, or use the hints provided in the lesson solution. And then, by looking at the description in the routine's header, figure out how you should call it tag to implement the task at hand. Okay.